Hey everyone, we're doing lesson 6.2 now. It's called Inverse Functions and Relations. This is a lengthy one. I got kind of a lot of notes here, and the assignment isn't super long. It's spread out. There is some graphing. There's a lot to this one. No other way to say it. Now there's basically two types of problems in here. The first type is about a page and then a little bit more. The second type is the whole rest of it. The ones with graphs and the one without are basically the same topic. We're just going to do a little more with the graphing ones. Okay, so math is full of inverses. You know that adding and subtracting are inverses, so are multiplying and dividing. Fraction and its reciprocal is a kind of inverse, positive, negative. It's just all sorts of things like that. So functions have inverses. If you have a function like 5x squared plus 3x minus 2, there's an inverse of that. There's a complete opposite in every possible way. And we're going to be looking at that as a topic. Now, at its basic level, when it comes to functions, inverses are where you switch the domain and range. Remember that domain is the x value, range is the y values. So here's a real basic function right here highlighted in yellow. This is just a 3-point function. We have 3 points paired up as coordinates. Well, if I take the x's right here and make them y's, and then I take the y's and make them x's, I have created an inverse of that function. Notice the y is now called y with a little -1 up there. That little -1 represents the word inverse. So these two functions are inverses of each other. And if you're given tables and then you're told to find the inverse, it's really easy. Just switch them around. Switch the numbers. 1, 5 turns into 5, 1. -2, 8 turns into 8, -2, etc. That's all there is to it. But we're dealing with equations, and this is much more challenging when you're dealing with equations. First of all, equation notation, we're going to be using function notation, f of x and then f inverse of x. So that little -1 still means the word inverse. So that's something you need to know. And we have two types of problems here, like I said before. The first type is to tell if two functions are inverses. If I give you two functions, f of x and g of x, and I ask you, are they inverses? The answer is either yes or no. The way to tell if they're inverses is to do this. Remember what that O means from the other day? That little O is the symbol for composition. So you have to compose f of g of x and you have to compose g of f of x. So you have to do the two functions composed both ways. When we did compositions, there's a first function and a second function. We have to give each one a chance to be first and the other one second. If you do that and both of them simplify out to equal x, then they are inverses. However, if even one of them does not simplify to equal x, then they're not functions. The second type of problem we're going to do is you're given just one function and you have to find its inverse. So there's this whole 4-step method for finding an inverse. And I'll elaborate when we get down there, but the 4 steps, we're going to switch notation. We're going to switch x and y, solve for y, which step 3 honestly usually takes a bunch of steps all by itself, and then change the notation back to inverse notation. So, two types of problems. I'm going to focus on the first type right now. State if the given functions are inverses. Now let's be real. If you go down, check the answer key, it says no, and write no and move on. I am not giving you credit for that. There is work to show here. So let's focus on that. How do you show your work? You're supposed to do f of g of x, and you're supposed to do g of f of x. F of g means we're going to do f of g like this. We're going to start with f, which is -2x minus 4, and we're going to plug g into it, -x plus 5 over 4. And we need to simplify this. How do you simplify that? Well, let's see. If we multiply, we put this over 1, and we can reduce this. And then all we have to do is distribute the negative sign in here. We get +x minus 5 on top, 2 on bottom, minus 4. And then to combine fractions, we need a common denominator, so that 4 we can change into 8 over 2. And that gives us x minus 5 minus 8 over 2, which is x minus 13 over 2. What the heck? Well, in order for these to be inverses, what I just did would have to work out to equal x. Just plain x. No extra numbers. No 13, no 2. This does not equal x. What that means is I'm already done with this problem. I can now state that it's a no. The fact that this already fails the test means I don't even have to continue testing it. It's just done. So that one's a no. So plug one function into the other function, simplify it doing all the math you can, and if it doesn't equal x, it's a no. Let's look at number 4. Are these inverses? So we got to do f of h of x, and we need to do h of f of x. So this is f of h of x. Start with f first. Oops, didn't mean to do that. So that's 8 minus 3x all over 2, right? I'm putting this function down first. That's supposed to be a 1. And I'm going to plug this function into it. So negative 2x plus 8 over 3. Okay, now how do I simplify this? Well, multiplying by 3 and dividing by 3 are opposites, so they cancel each other out. That's very convenient. That gives me this. Those 3's cancel out, that's what I get. Now I can distribute this negative sign. I get 8, let's see, negative is plus 2x. Negative to positive is minus 8. The 8 and the minus 8 cancel each other out. That gives me 2x over 2. And the 2's cancel out, just gives me x. So does that mean that this is a yes, right? Because up here, you do compose one function to the other function, and you get x, right? But you also have to do it the other way. So now I need to swap these around and see if I still get x. So h is now the first function, h of f of x. So I need to write this one down first now. So that's negative 2x plus 8 over 3. Where the x is, that's where I put parentheses. Inside of those parentheses, I need to write 8 minus 3x over 2. All right, what happens here? Well, once again, we have 2 times 2 divide, times and divide cancel each other out. So I get negative 8 minus 3x plus 8 all over 3. That negative sign distributes, negative 8 plus 3x minus 8 over 3. The minus 8 plus 8, that cancels out, giving me 3x over 3. The 3's cancel, I get x. The fact that I got equals x for both of these means that number 4 is a yes. These two functions are inverses of each other. And if you take the time and sort of process this through, maybe it's going to seem kind of obvious. In the first function, if you do order of operations, you're going to multiply by 3 first, then subtract it from 8, and then divide by 2 last. Here we're going to multiply by 2 first, and it's going to be negative instead of positive. And then we're going to add 8 instead of being subtracted from 8. And then instead of multiplying by 3, we're going to divide by 3. So everything in each function is sort of the flip-flop or the reverse of everything in the other function. All right, let's try this one. Are these inverses? I can already tell they're going to be no because they're completely different types of roots. But let me be honest about this and show the work like I'm asking you to do. G of f of x means g of f of x. And then the next thing I would be doing here is reversing it. But I have a feeling we're not even going to get to that point. So g of f of x, I write g first, the cube root of negative x plus 1. I wrote this one down first, right? I put parentheses where that x was. inside the parentheses, I need to put the fifth root of negative x minus 1. Okay. Simplify that. Well, all right, I admit, that's barely even written in English. The fifth root of negative x minus 1. Okay. Can we combine like terms like this minus 1 and this plus 1? No, because that minus 1 is underneath the root, and it's sort of stuck in there. It's an order of operations thing. Can I cancel out any roots? No, roots don't cancel each other out. Powers cancel out roots. Nothing here simplifies. Nothing, period. If you look at an actual problem that's a yes, and I want you to refer back to this, things cancel. Times 3 divided by 3. Positive 8 minus 8. Times 2 divide by 2. That kind of thing has to happen in order to get a yes out of one of these processes. Here, nothing cancels. In fact, nothing even simplifies. When you plug it in and set it up, there's no work that you can possibly do. Number 6 is automatically a no. There's no simplifying. And once it's a no, that means you don't have to do any more work. So to be a yes, you have to do both steps. To be a no, you only need one step to fail. All right, let's look at this one. Now this one also has a fifth root in it, right? Kind of like this one, but it has a fifth power in it. And if you think about raising things to powers and taking roots, they're kind of opposites of each other. I get a good feeling that this one's going to be a yes, but let's check it. F of h of x, h of f of x. Okay. This means we do f first and plug h into it. F first is that. Negative x minus 2 to the fifth power. And I need to plug this in there. Negative fifth root of x plus 2. All right, that's kind of sloppy. Yeah, I can't let that go. I need to rewrite that better. Okay, hopefully that's better. All right, so what do we have here? Well, first of all, this set of parentheses don't really do anything. They're just showing me where to plug something in. So my first step, I can just drop those parentheses. My second step, I have plus 2 minus 2. Plus 2 minus 2 cancel each other out. Next, I have a root and a power. If you raise something to the fifth power and then take the fifth root of it, they cancel out, leaving us with negative x. And then finally, a double negative equals a positive. This equals positive x. So remember, in order to be a yes, you have to get positive x, or just plain x. But you also have to get it the other way. So let's look at the other way and see if that works out also. So h of f of x. Start with h. So that's negative fifth root of x plus 2. So I copied this down first, and I put parentheses where the x was. Inside of the parentheses, I'm going to write negative x minus 2 to the fifth. Wow. Can you read that? I can't. I just can't. Hopefully you got a chuckle out of that. If you don't understand, it's okay. Negative, oops. Oh, why am I struggling here? Negative x minus 2 to the fifth. There. Okay, so I plugged the second function into the first function. Now what happens? Well, once again, we have a fifth root of a fifth power, and those cancel each other out, giving me negative x minus 2 plus 2. A negative, what happens to a double negative? They cancel out, leaving me with x minus 2 plus 2. What do those parentheses do? Nothing. X minus 2 plus 2. And minus 2 plus 2 cancels, just giving me x. So the fact that both of these work out to equal x means that number 8 is a yes. All right, we're only about halfway done with this assignment. If you get this far, great. If you have trouble doing this on your own, contact me. I will set up a meet and I will go over this with anyone who needs help. But we are into the second set of problems. Find the inverse of each function. So that's right here, this 4-step method for finding an inverse. Switch to y notation, switch x and y, solve for y, switch to f inverse notation. So 3 of the 4 steps aren't really doing math. The first thing you're going to do is write this as y equals negative 2x plus 2. The reason you do that is there's going to be a whole bunch of steps, and if you have to write f of x over and over and over in multiple steps, and then you have to subtract f of x from both sides and do this and that and everything else, it just becomes a big hassle, a big pain in the anatomy. So switch f of x to y. Then, so that's step 1. Step 2, switch x and y around. X equals negative 2y plus 2. That's the inversion right there. We're inverting the x and the y. Step 3, solve for y. Well, step 3 usually takes a few steps, and I'm going to do this one in a different color so it stands out. So here, let me do 3 in red. So how do you solve for y? Well, I'm going to minus 2 on both sides. X minus 2 equals negative 2y. Then I'm going to divide both sides by negative 2 and get x minus 2 over negative 2 equals y. Now, that y is isolated. And so our process says the 4th step is to what? Switch back to f inverse notation. So change the y into f inverse of x, and then just bring that part of the answer down. And that should be the inverse. Now, before I check the answers, I'm going to tell you, many times textbook authors or people who write, these math software do not like a negative in the bottom of a fraction. And sometimes you'll see where they multiply by negative 1 over negative 1. Negative 1 over negative 1 is positive 1. So when you multiply by it, it doesn't really change the value of your answer. It just changes the way things look. So if you distribute this, you get negative x plus 2. And if you multiply that, you get over positive 2. So this may be the answer, or this may be the answer. So I haven't cheated and looked ahead before the problem started. I just want to prepare you for the possibility that you might get one answer which is totally right, and then you check it and there's a different answer which is also totally right. All right, let's check this one. Well, if I can ever get there. Yeah, they did it the second way that I did it. So the first way I did it, I came up with this. They multiplied by negative 1 over negative 1. Distribute, again, negative x plus 2. Multiply here over positive 2. So if you get an answer that seems right in your head and it looks close, but the negatives and positives are just a little different, that's probably what's going to happen. All right, let's do, where am I? Number 12. So this one has a power in it. All right, step 1. Y equals x plus 1 to the 5th minus 2. Step 2. Switch x and y around. X equals y plus 1 minus 2. Step 3, I'll do in red, because step 3 is really multiple steps. Solve for y. I'm going to first, I forgot something. Hold on. There's a 5th power right there I forgot to bring down. Okay, so we can start by adding 2 to both sides. X plus 2 equals y plus 1 to the 5th power. That cancels out. Now we need to cancel the 5th power. What cancels a 5th power? Answer, a 5th root. And if you do the 5th root on one side, you have to do the 5th root on the other side. The index and the power cancel out. You get y plus 1 equals the 5th root of x plus 2. Now, is y isolated? Not yet. We need to subtract 1 to cancel that off. Subtract 1 over here. And what you end up with is the 5th root of x plus 2 minus 1. Notice I did not combine the plus 2 and the minus 1. these are kept separate because the 2 is under a radical bar and the 1 is not under a radical bar. So they're kind of like, you treat them almost as though they're unlike terms, and you just keep them separate. So now the y is isolated. I do step 4. So I'm just going to write my answer. F inverse of x equals, and then I basically copy that down. The 5th root of x plus 2 minus 1. Let's check number 12 and make sure I did it right. And there it is. Oh, h inverse. Hold on. Not that this is a minor detail, but the original problem had h, right? So when I change it back, I'm supposed to make that an h. Duh. All right, let's look at number 14. Step 1, y equals the 5th root of x plus 1 plus 2. Step 2, x equals the 5th root of y plus 1 plus 2. Step 3, isolate y. So I'm going to subtract 2 on both sides. X minus 2 equals the 5th root of y plus 1. To isolate y, I need to cancel out a 5th root. What cancels out a 5th root? A 5th power. If it was a 3rd root, I'd use a 3rd power. So you just need to make sure that those numbers match. And then what you do on one side, you have to do on the other side. All right, those cancel each other out. I get a y plus 1 over here and an x minus 2 to the 5th over there. Is y isolated? Not yet. I still have to minus 1 to cancel that out. X plus 2 to the 5th minus 1 is just x plus 2 to the 5th minus 1. Now, what you could do if you wanted to, like if you had a ton of spare time, you could do x minus 2, 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 minus 1, and then start foiling all of this together. Oh, wouldn't that be a blast? No, no one wants to do that. That's awful. So we'll just call this the answer. No, getting ahead of myself. Step 4, we have to rewrite it back the way it was. So it started out as g of x. This is going to be called g inverse of x equals x minus 2 to the 5th minus 1. All right, let's check number 4. No, that's not number 4. What am I doing? What am I talking about? 14. There it is. Clearly, you can see there's a lot of work to show. Do not slack off on showing the work. All right, next, find the inverse of each function. That's what we just did. Then graph the function and its inverse. So, okay, this is going to have a lot of steps. Step 1, y equals x minus 14 over 3. Step 2, x equals y minus 14 over 3. Step 3, well, nope, step 3 is the one that I do in red, right, to make it stand out because it's kind of unique. It's got its own set of steps. How do I solve for y here? Well, the y is being divided by 3, and the opposite or inverse of divide is times, so I'm going to times both sides by 3. I get 3x equals y minus 14 because those 3's cancel. Now I can just add 14 to both sides. 3x plus 14 equals y. Step 4 is just sort of finalize your answer. What did it start out with? F of x. So f inverse of x equals 3x plus 14. So that should be my inverse, and then I have to graph them both. I'm going to check, though. I don't want to graph something if I got it wrong. So 3x plus 14. Oh, I'm scrolling like crazy. Where am I? Okay, here we go. 3x plus 14. Now I need to graph both of those. And yes, I am going to use Desmos. I don't expect you to graph these by hand from scratch. So the first one, y equals fraction bar x minus 14 on top and 3 on the bottom. So let's see, that has a, that's a, what am I doing here? If I go like this, then hit the home button, there we go. So the y-intercept is almost down there. Looks like 5, -3 is a point right there. So there's a line like that. Then I have to graph the other one, which is y equals 3x plus 14. And they seem to meet at -7, -7. Well, that would be way down here. This one has an intercept of about right there. And the line sort of goes like this. Okay, here's the deal with graphing inverses. It's a way to tell that you did your work correctly. So if you want to be able to check your work, now I'm not talking on the answer key. You know how to check yourself on the answer key. But let's say you're doing a test and you want to check your work. So this was the problem right here. And this is the answer that you got right there. Well, graph them both on Desmos, then graph y equals x. That's the diagonal line through the origin at 45 degrees. If your two graphs are mirror images of each other, you did it correctly. So the purple graph and the green graph are reflections. If the black line here through the center, you think of that as a mirror, the red and green are reflections of each other. That means you did it correctly. All right, we'll see that on another one as we go through here. Let's do number 18. So I need to get that out of the way. I need as much space as I can get to write. All right, step 1. Y equals -4 minus 5th root of 16x over 2. Step 2, x equals -4 minus 5th root of 16y over 2. Step 3, isolate y. So I'm going to start by multiplying both sides by 2 to cancel that 2 out. 2x equals -4 minus the 5th root of 16y. Now let's see, how about if I add 4 to both sides to cancel that out? 2x plus 4 equals the -5th root of 16y. Ooh, there's a lot of work to do here. To cancel out that negative, now that negative is like having a -1 being multiplied there. So I want to divide by -1 to cancel that negative out. If I divide by -1 here, I get -2x minus 4 equals the 5th root of 16y. Now, I want to cancel out 5th root. I can do that by raising to the 5th power, which means I have to raise this side to the 5th power. So -2x minus 4 to the 5th power equals 16y, because these cancel out. Is the 16 isolated? Not yet. I mean, the y isolated? Not yet. I have to divide by 16. And I'm finally able to now do step 4, which is to rewrite it in the proper notation, g of x. So g inverse of x equals -2x minus 4 to the 5th power all over 16. Let me change that to a better handwriting 4. There we go. Now, before I graph anything, I'm going to check my answer. What number is this? Number 18? Number 18. Ooh, that doesn't look right, does it? Oh, but it is. But it is. Oh, how do we explain this? I really don't want to explain that. This is the right answer. Tell you what, I'm going to go ahead and graph these, and then I'll explain why this answer looks different on the answer key. So, yeah, I'm going to say I would accept that as correct. Anyway, how do we know it's correct? Well, let's graph this. So y equals fraction bar -4 minus the 5th root. So 5th root, you go functions, miscellaneous, and in the middle column, there's something that looks like n root. You put a 5 here for the index, and then under the radical, I can put 16x. Or did I say 5x for the index? You put a 5. And then down there, I can put my 2. And that's what that graph looks like. Oh, my dog is on my lap. He woke up, and he's probably going to start barking. And then so I get a curve kind of like this and a curve kind of like that. Not perfect, but we'll call that good enough. Now for the next one, y equals fraction bar, so I need parentheses, negative 2x minus 4, and that's raised to the 5th power over 16. And so I have an intercept at negative 2, 0. Notice one intercept is negative 2, 0. The other one is 0, negative 2. Also, where they meet is the exact same point. So this goes like this and like that. And then finally, if I were to graph y equals x, this isn't part of the instructions, this last step. I just do that because I know that if I pretend like that line is a mirror, and then the other two graphs are reflections of each other, that means they are correct. So that means that this is the correct answer, even though it doesn't look like that. Now, if you're content and you're happy, you can stop the video right now and get to work. But I am going to explain their answer down, where is it? I'm going to explain how this answer comes about. So if you want to take the extra time, here goes. So here's what they did. Nothing yet, but if you look at this as an expression, you can factor out a negative 2. We've done plenty of factoring. This is called common factoring. Now you can apply this 5th power to the negative 2 and the x plus 2. So it becomes negative 2 to the 5th, x plus 2 to the 5th over 16. So what's in these parentheses got factored, and then you apply that power to both factors. Negative 2 to the 5th power, negative 2 times negative 2 times negative 2 times negative 2 times negative 2, 2, 4, 8, 16, 32. That works out to equal negative 32 x plus 2 to the 5th over 16. Negative 32 can be divided by 16. 32 divided by 16 is 2. So that gives you negative 2 x plus 2 to the 5th over 16. And this is the answer that they got down below. I would not expect you to do all of this work. So you keep your answer like that, and you're good. Okay, going to stop there. Give me a holler if you have trouble. If we can do a virtual meetup in my regular, Algebra 2 on Mondays and Thursdays at 1 o'clock, I have the class meets. I can work through any or all of this assignment if you need that kind of help. Or just reach out with an email and I'll communicate with you individually. Otherwise, I will talk to you later.